Great. Okay, I'm looking around. Everybody's got their cup with their colored water, and it looks like they turn different colors.
Second line of inquiry is all about how water is captured, how we get it, and what we do with it. And our water has to be of a certain quality. So we're going to talk a little bit about how water quality is measured. How scientists find out about water quality. If it's good water for living things or maybe not so good water. Or our concept is function, how it works for us. And I'm going to introduce us. Boys and girls, can you please give a warm hello to Mr. James?
We have 100 school groups around Colorado that are monitoring the water quality of our local rivers and streams with the State Water Commission. And one of the things that we test the water for is its pH or its acidity. In science labs, there's often a lot of equipment and materials we have to manage. And so that's the other reason why we got to really cooperate. But it makes science fun because you got to cooperate together so you can achieve your goal and do your lab. So,
we only need this one.
Okay, good. You guys are making good progress. Okay, this table's going to is that we use the scientific method to investigate the world around us. That's how we learn about stuff, using the scientific method. And in the scientific method, we want to know what is it that we want to find out. That's our question. And why do we want to find it out? What do we predict is going to happen in our experiment, and why are we predicting that? At your tables, I've got a lab. This is your first science lab. This is the kind of lab you do for kids. So this is really cool. Has anybody ate already? Everybody's ate. So I've been doing labs with 12 and 13-year-olds a lot. You guys are young. So I want you to experience this and have a really good time, a good experience.
It means that the water's too much.
Lab paper looks like this, and I put it on the document camera as well. And what we're trying to find out in this lab is a question, how acidic is the water? Watch, one of the things we test for is if the water is acidic or not. Repeat after me, acid.
Acid.
Acidity.
Acidity.
Now the opposite of acidity is called alkaline. Say alkaline. Alkaline. Okay. Okay, good. So, do you think that all water is the same?
No.
No. Okay. It's not. Now, in Riverwatch, we call the acidity the pH of the water. pH stands for something to do with the water. Does someone know what the chemical name for water is? The letters? The chemical name? The gentleman in the green there?
H2O.
Yes, H2O. What's the H stand for?
Hydrogen.
Hydrogen, very good. So the 2 means there's 2 hydrogen molecules and they're bonded or attached to the O. What's the O?
The oxygen.
Oxygen, okay? So pH stands for percent hydrogen. Water that is more acidic has more hydrogen in it. Water that's more alkaline has more oxygen in it. Now, this is a higher level concept that you'll understand more when you're in middle school and high school. I'm just introducing it to you. There's a pH scale that goes from 0 to 14. The middle of it, which is 7, is called neutral. It's not an acid, it's not alkaline. Another word for alkaline is base. You'll hear the word base or basic. So 7 is in the middle, it's neutral. Below 7 is acidic. Because if it's too acidic, it'll make the fish sick and it'll kill them. And too acidic is not good for humans either. It's going to be really cool for you guys to do this lab because you're going to have to really practice your skills of cooperating with each other, following directions, and especially using your life skill of patience because you have to take turns with the equipment.
And then I had like turquoise, which is about here. You got the dark purple, and you got the yellow.
Scientific method, we always stay very organized. our materials. We're going to use water samples today, graduated cylinders, plastic cups, and pH indicator. We make a prediction or a hypothesis. In this case, when we test these water samples by putting the pH indicator drops in and seeing what color the water turns, the water is either going to be the same or it's going to be different. And we predict that we don't know. You don't know what water. I could have tricked you, and all the water might be the same, even though it's labeled
It might even
different.
stay the same.
Yeah, it might stay the same.
The way it is.
But so we're not really sure, but we know it's either nothing's going to happen or something's going to happen. They're going to be. You're going to have 4 different kinds of water. Each person is going to have a cup. When we're measuring the volume of water, we use a graduated cylinder. We're going to be teaching you how to measure water. Let's start with the person at the table that's closest to this side of the room. That's who I'm going to give it to first. And then we're going to go around in a clockwise fashion, like the way the hands of the clock go around. Screw the cap, and you're going to hold the bottle in your hand, cap in the other hand, and you're going to put in 5 drops into your container of water. Then you're going to put the cap back on and screw it back on to make sure it doesn't spill, and you're going to hand it to the person on your left. That'll be clockwise going around, and then you're going to give yours a little stir. Let's make another prediction here. No, everyone has water from different parts of Colorado. We know that the rocks are different in Colorado. So, do you think the mineral content of this water is all the same?
No.
Probably not. So the pH, whether it's acid or base, is probably not the same. When the water runs off, remember the water cycle, when it rains and snows and then the water runs off in the river, it can pick things up that affect what's in the river. Now look at these drops. What color does that appear to be? This is cool. You're putting in red drops into clear water. Do you think it's going to change the water? Is the water going to stay clear? What do you predict is going to happen?
For some water, it might mix up and turn to the color.
I mean, we're putting red drops in. That's what's kind of cool about this experiment. You're going to put your 5 drops in, you're going to put the lid back on, pass it to your partner. You're going to stir yours around and see what color it turns. So I'm going to start passing them around. Remember, 5 drops here.
1, 2, 3.
Yeah, put it down. Ooh.
So now give it to him.
Okay, now it's Claudia. Blue. Okay, we'll sing.
Now this pH indicator, it's a chemical that can tell what the acidity is. And depending on what the acidity is, it changes colors, which is kind of cool. Now, in fact, we've got something here called the pH color chart. And you're going to get to be using this after you put in your drops and it's changed colors. You're going to look at the chart and you're going to compare. If it turns yellow, it means it's very acidic. If it turns green, it means it's neutral. Now, if it turns blue, it means it's alkaline. And if it's really purple, which is going to be on this edge, then it's very alkaline. You're going to circle which color yours turns. Say yours turned purple. You circle purple. That means it's very alkaline, not acidic at all.
Mine is so light. Look how light it is. Mine's acidic. Mine is Aiden, you got light color. No, yours is purple. Mine's acidic. Mine's purple. Oh gosh. Mine is right here. Mine's yellow.
And then you're going to record your conclusion. Was your water acidic, neutral, alkaline, or very alkaline?
What does mine mean? It's yellow. This is mine now.
That's green.
Mine's acidic.
Mix them together in the waste bucket, the purple and yellow.
It's green. It's neutral. It's neutral.
You guys did an awesome job on that experiment, and you probably have some ideas, things you're thinking about. Now, when we do experiment, we always want to do our conclusion. What did you learn? Think about this a second. you learned a bunch of different things. When you learned how to do an experiment, follow the scientific method, follow the procedures. You also learned some things about acidity, and that all water is not the same acidity. Turn your paper over, share with a partner what you learned. I'd like this to be a quiet time of reflection. You did a really nice job.
Boys and girls, Mr. James, a nice thank you.
Thank you. Thank you.
Very
Neutral. Someone, what does that mean? Me?
What does that mean?
It's still safe for fish. It's still safe for fish. Yellow's not safe for fish.
Go ahead and pour the other two in there as well.
There's green. It's neutral. It's neutral.
Cool, huh? It's science. It's fun. Yes, it can be.
I thought that it turned blue because of its salty smell. But I was wrong. And so I'm neutral, and then Sophie got very,
Thank
it's
you.
very
Everyone just stop
high
for a
on the
minute,
scale.
give her attention.